Okay, hello everyone. Thank you very much for coming. And we're gonna talk about security vulnerabilities in this session. We're gonna do some live hacking, and this is gonna be an interactive session. So I'm gonna try and breach existing application libraries. And we're going to do it based on your suggestions. So we're going to hack some applications. The applications are not live. They're not on the web. They are real libraries that we're going to be using, but it's in a safe application which we have created. So we're going to be attacking real live vulnerabilities and exploit real live libraries. So my name's Simon Maple, at SJ Maple on Twitter, if you'd like to follow. I work for a company called Snyk, which tests for known vulnerabilities in existing dependencies in your application. So we look for known vulnerabilities and we tell you about vulnerabilities that you have in your application that you need to fix. A little bit about myself. I'm one of the founders of the Virtual Jug. I help run the London Jug as well, and a whole bunch of other things that I do. But I used to work for IBM on WebSphere App Server. Any IBMers, any WebSphere App Server users here? Just use WebSphere. Okay, I'm really sorry to hear that, but you know, I was only there for 12 years or so. Then I moved over to Zero Turnaround. JRebel users? Any JRebel users here? Obviously the WebSphere person's a JRebel user, right? And now I've moved across to Snyk, looking at security vulnerabilities and things like that. So, who's heard of DevSecOps? No one, huh? Well, who's heard of DevOps? Right, and whoever hasn't got their arm up has probably got a problem with their arm or their elbow or something, right? Because everyone's heard of DevOps, right? Now, DevOps is a very well-known way of getting code out to production very, very quickly, being able to do it repeatably, being able to involve operations teams earlier, so that we don't have as many issues as we might typically have if we're just having developers in the meetings by themselves. So, what the security team thought they needed was, why don't we be cool as well? Why don't we add sec in the middle of dev and ops, and we can have this cool new name as well? And it's actually really important for a number of reasons. These 5, but the one that I think is the most important reason as to what the problem is behind DevSecOps, or the reason DevSecOps is needed, is the second one here. Everyone's delivering very, very fast to production. Okay, who delivers daily to production? Number of people. Who delivers weekly to production? A much stronger number. Monthly to production. Who does security audits on every release? One person, the WebSphere person. 2 people there. I knew. You see, it takes an enterprise, right, to really care about these kind of things. Now, one of the things that we care about as we reduce our time to going to production is the fact that we do care about security vulnerabilities that are placed into these applications. So there are a number of things which are lacking. But 2 of the key things here is the organization's reputation is on the line, and effectively customer user data, sensitive information, which if it was our information, we would care very strongly about. This is the information which is at risk. So we look at how bad the situation is. Well, almost 60%, almost 2/3 of Maven packages that have been indexed in Maven Central have remained unfixed when known vulnerabilities exist. Okay, so very often, even when known vulnerabilities are people are made aware of known vulnerabilities, typically people don't upgrade, typically people don't fix. So we do have a problem here. Who's heard of Equifax? Yeah, for all the wrong reasons, I'm sure, right? People hear about Equifax because it was one of the major breaches, which I can't remember what the number was, 140, is it? 143 million US customers had their personal data breached, okay? And because of a Struts issue. Now, for me, I hate talking about Equifax because it's one of the most overused examples when we talk about security. But the key thing for me here is this graph. And this graph shows the attack timeline on the Struts framework. And what it goes to show is how many attacks there were on the Struts framework in a very short amount of time, because when a vulnerability exists in a project or a library, one of the great things and worst things about open source is everyone shares these libraries. So when a vulnerability exists in an open source library, all of a sudden you have an attacker has a vast number of potential targets that they can try and breach. So open source is great. Open source can also be pretty bad on security from that respect. Any Struts users here? I'm not going to pick on you anymore. This is not fair. Okay, so let's pick on JavaScript instead, because it's easy and fun to pick on JavaScript. So yeah, NPM, actually, when we think about repositories and code repositories, NPM is pretty much, the biggest out there. Over 400 packages that have been indexed, over 6 billion downloads per month, and over 70,000 people who have actually indexed packages, who have provided packages up to NPM. This is another scale. This just goes to show how adopted something like open source software is. And I'm going to show you your app. I hope you don't mind me showing this sensitive code here. But this is your app. But when we think about your application, your code, the code that you physically write in an IDE, is actually tiny compared to the application which you deploy. I'm going to give you an example of this, and this is just a simple, you don't need to read the code, it's just a simple serverless application which grabs a file and stores it in Amazon's S3. Very, very simple. Here we have 19 lines of code, which is code that the developer has written themselves. Any guesses on how many direct dependencies this code pulls in? 20? 11, only actually two direct dependencies. But you're actually closer when we think about, you're actually pretty close when we think about the indirect dependencies, right? Which is, I'm sure, what you were thinking when you answered, right? So there we have almost 20 indirect dependencies. These are transitive dependencies, yeah? The dependencies whereby if I depend on X, X is going to depend on B and C and so forth. And we actually build up our application hugely. How many lines of code do you think exist in my application now that I'm going to deploy? Hundreds? Thousands? Hundreds of thousands? Almost 200,000 lines of code. Okay? Now, when we come back to think, yeah, my tiny little app has 19 lines of code, we're actually deploying 200 lines of code, 200,000 lines of code. Okay? This should give us the idea of scale of what we're actually delivering into our production environments. And when we think about this, think about two things. First of all, just by the sheer numbers here, 19 and 191,000, where are your security vulnerabilities likely to exist? Okay, so think about that for one. Also, think about, when your security vulnerabilities exist here, this isn't just one application. This is code that is existing in hundreds, in thousands of other applications. Okay, so when attackers try and target, they target this open source code that is available all over the web rather than just in one application. I'm going to probably mention that many, many times, and you'll get bored of me. So, open source usage has exploded, and it has exploded because one vulnerability means many victims. I've done too many slides already, almost 10 minutes in. So we're going to hack. We're going to hack some known vulnerabilities, some live code, and we're also going to talk about how you can test for your vulnerabilities in your applications, and how you can find and fix issues. So first of all, I'm going to ask you a question. Who does security testing of their vulnerabilities? Of their dependencies, sorry. Like 10 people maybe in a room of maybe 100, 200. How many people know how many direct dependencies their application has? Like 25 people, maybe. What about indirect dependencies as well? We're down to 3.5 people, 4 maybe. Okay, this is the scale of the problem. Very often when we write our own code, we're very concerned about the security. But if we don't even know the security of our open source projects that we pull in, or even the dependencies and the number of dependencies they're pulling in, how can we claim our application is secure? So let's start hacking. Okay. All right, so what do I have? Let's start with Java. And I'm going to show you a number of applications. I'm going to show you a number of applications, and I'm going to show you I'll show you a Spring the actual Struts vulnerability, and then we'll actually move over to Node, and I'll show you some of those vulnerabilities as well. The key thing here is, though, it doesn't matter whether it's Java under the covers, Node under the covers, even PHP, all right? I won't swear again, I promise. But it doesn't matter what is your implementation code. A vulnerability is a vulnerability. If it's a directory traversal, it's the same vulnerability, whether it's in Java, .NET, or whatever, okay? So we're going to focus more on the vulnerabilities. Now, who's heard of, should we start, well, let's start with struts. Okay, so we're going to talk about struts. There are quite a few people in the room. Now, the struts vulnerability was an interesting one because when attackers try and break into code, they actually try and find an error path. And typically on an error path, you essentially get there's less predictability from the application point of view. As a result, with less predictability, you tend to avoid sanitization, you tend to avoid checking. There's a whole bunch of things that you actually avoid by going down that route. Now, the struts vulnerability was actually one that went through an exception path. So, the exception was caused, and I believe it was when the exception.getMessage invocation was called, that was where the actual execution of the remote code was put in place. Now, with this Equifax, this is the same bug that was found in Equifax, and I'm going to show you this now. This bug, it takes an amount of time for a bug or a vulnerability to actually not just exist, but be exploited. We're not talking about, someone breaking in and 5 minutes later they run away with 140 million records. We're talking about a number of weeks, a number of months in which attackers exist on your system, unbeknownst to the people actually running this application in production. And they are essentially knowledge gathering. They are trying to find information about your application, about your environment, to try and find where your sensitive information is, the best ways of trying to get and breach that sensitive information. And with Equifax, this took, I think it was 1 to 2 months to actually, I think it was 1 month actually, to try and gather this information. The key thing is, Equifax didn't even realize they were breached for a further month. Okay, so we're not just talking about how can you protect yourself, how do you even recognize when you're breached? So let me show you this breach. First of all, I'll show you the application. The application is, actually I'm going to run this on, I'm not going to run things too much on my local machine. I'll show you my email for a little bit more though. I'll show you Pivotal. Yeah, I'll do this on Pivotal first. So here we have a Pivotal Web Services environment. I'm going to run this Java Goof application. And in this Java Goof application, it's effectively just like a to-do application, to-do list. So I'm going to sign up. I'm going to pass in some of my details. So Simon, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Yes, I work for a security company, and that's my password. So this is my to-do list. I can create to-dos if I wish. Create a name. Let's buy my wife flowers. That seems like a nice thing to do. Have a due date of 1970. We better make that high, I guess, if it's 1970. Create, and all of a sudden we have our to-do list. I can add, remove, edit. Just a regular to-do list. But if I click on my About here, we can see an amount of things. And obviously, it's not quite this easy for attackers, but we can see which version of Struts we're using. You can see we're using an old version of Spring, and we use Hibernate because we like to make poor life decisions. I'm going to now attack Struts 2. So one of the interesting things about Struts 2 is the actual exploit is based on a payload that occurs in the header. We don't need to set up anything. We don't need to make a build-up before we actually try and expose this. If you are running Struts 2, we just need to pass, invoke an endpoint with this exploit. Now let me show you what we actually need to do. It's struts exploit headers.txt. So if I was to cat this, this is the payload. This is the combination of characters that we need to pass. And obviously, no one quite as stupid as me would put this together. This was obviously some smart attacker somewhere that has learned to put this together. And what we can do is we can substitute this string here, this command string, which is on a couple of lines there. There we go. That command string, we can substitute this command string with whatever command we would like, and then we can execute this command remotely on the machine which is running the application with struts. So I am going to run, let's cat this. This is the command I'm going to run. So I'm going to Copy paste this. So I'm going to cat this out. I'm going to substitute the command for, in this case, /env. I'm going to run that. I'm going to curl that against an endpoint. Let's not use the local host, though. Let's do the Java Goof application. So this one here. I'm going to hit it against that endpoint. I run that, and all of a sudden, it doesn't work. Let's see what's happening here. Actually, I wonder if I fixed it in this application. I think I may have. That's okay. I have plenty of other vulnerable applications. Let's run this against Heroku. Instead, this is the same Java Goof application. It's lovely to have so many vulnerable applications that I know how to break. Oops, no, that was a get. Like that. And did this work? Okay, nothing wants to work anymore. Oh no, that just... Let's try that again. Oh, there we go. Okay, so this is my response. So I've now got the /env from that Heroku endpoint on, running in that Heroku cloud. Okay, this is remote code execution. So I'm sending it /env. It's running /env on my Heroku environment, and these are my environment variables. Who holds passwords and usernames in environment variables? This is a safe room. You can put your hands up. Don't worry. There we go. One person, 3 people, 4 people. Okay, we're getting a little bit more confident now. I think there's probably about 30% of people probably do that, if we're honest. This is a great way of finding more information, finding how we can access databases, finding out a whole bunch of things. If I wanted to. In fact, if I was to go back and run, that was in here, wasn't it? If I was to run this command instead, now all we're going to do is actually we're just going to run a cat command, and this cat command is simply going to cat out my etc password. So if I was to go to the top and grab this URL, all of a sudden, hopefully, this is going to cat our etc password. Is it? Okay, my Heroku app doesn't have an etc password by the look of it, but that's fine. If it was my local machine, I'd actually get a nice etc password. I'll show you another example of that. But yeah, this is typically the Struts vulnerability. Who's a Spring user here? Yeah, virtually everyone. Who is a Spring Data user? Who is a Spring Data REST user? 2 people. Who's heard of, between you two, who's heard of Spring Break? Anyone heard of Spring Break? And that's not like the American vacation. This is like an actual vulnerability. So Spring Break is a remote code execution that exists within Spring Data REST. If you are running Spring Data REST, you are likely, between these versions, you are likely entirely vulnerable to a remote code execution. And I'll show you this running. For those of you who, in fact, I can probably show you some code here. For those of you who have not used Spring Data REST, yes, here it is. So in Spring, I have my domain object here. This is just a grocery. This is a grocery list application. So here's my grocery list. I have just an ID, a name, and a cost. I'm using Spring Data. As a result, I have this item repository. This item repository, This item repository is an interface. It allows me to extend a CRUD repository, and Spring Data is awesome in that it implements a whole bunch of the kind of backing code, which will allow me to invoke this interface and actually have access to read, write, update my back end. What I can also do is add this annotation here, which is the repository REST resource, and this is the annotation that allows me to have access to my data now through RESTful endpoints. This is great. So if I was to go to, and this is the one that is in Spring, if I was to come here and I was to click on Spring, my Spring Break application, here I can actually just type in items, When I run items, this is just actually a Spring. This is running as a Spring Boot application. When I run items, you can see the items that are in my data set here. We have beans at 50p, milk at £1.09, and so forth, and a whole bunch of other things. I can, if I wanted to, put items/2, and I get that specific JSON object back. So the usual kind of RESTful interface. But what I'm going to do is, if I come over here and I cd spring goof, in here there's an exploits directory, and there is this piece of code here. This again is the payload which I would need to actually send in order to have this execution running. This actually comes through from something which has been found a number of vulnerabilities in Spring before, called SPEL, the Spring Expression Language. And the Spring Expression Language allows us a kind of richer search on our data, but what it also allows us to do is, in this case, what we're actually going to be doing is getting our runtime and executing whatever command we want on here. So if I was to, for example, cat my Spring REST exploit password, if I was to curl this, what we're going to do here is we're actually, this time, hopefully it's going to work, we're going to grab our etc password and cat that out to the runtime. So instead of running this on my local host, I'm going to run it on this Spring Break endpoint. There we go. If I run that, this is now going to execute this, and we get the username password file on the Pivotal Web Services machine. At this point, I can pretty much run whatever I want instead of running cat/password. I can do an ls, I can do a ps, and one of the interesting things that attackers will do is they'll hide their tracks. So if an attacker was to overwrite ls, what they'll tend to do is hide things that they've installed. So if they've installed things in a certain directory and you type ls, you won't be able to see the directory they've installed in. It's very, very similar with ps. They'll hide their running processes that they're running to monitor the system. So what else can I show you? Who's heard of zip slip? No one. So zip slip, it was a vulnerability which we, SNCC, our security team, disclosed only a couple of weeks ago, last week maybe. And it's a vulnerability which has existed for many, many years, but has been extremely prevalent in a number of languages and very specific to Java. So I'm going to show you what it is. This is actually in my Heroku application. Is this Heroku? Yeah. So in my Heroku application, I'll have to sign in again. Can anyone remember my password? There we go. How good's that? Crowdsourcing. Oh, login error? Seriously? I typoed it, did I? Hang on, let's just register again. SNCC, Simon. Okay. Cancel that. Right, this time what I'm going to do is, what I can do here is I can click on Upload Files and I can view files. The files are in the public folder, and when I click on Upload Files, it's going to extract a zip file. Now, zip slip is a directory traversal vulnerability, which exists specifically for zipped archives, or archives in general. Who knows what a directory traversal is? What would you say a directory traversal is, sir? What would you say a directory traversal is? Yep, exactly that. So if you have a target directory, and the application would expect you to remain in the scope of that target directory, but what you actually do is you break out of that, and the gentleman's right, you can either potentially read or even write. And writing is what we're going to show today with zip slip. It's the ability to overwrite files in the file system using an archive which has directory traversal in its path. Who realized in a zip file you could have .. in your path, that when you unzip, it actually goes outside of the target directory. Anyone know this? Yeah, only about maybe 5 people in a full room. So one thing we're going to do now is we're going to choose this file. The file we're going to choose is called zipslip.zip. And before I click on upload there, I actually just want to show you, where did I put it? It was in Java Goof. Exploits. I'm going to show you what's in this. So I'm going to jar -tvf zipslip.zip. .zip. And in here, we can see what we have is we have a good.txt and we have a .. all the way out, all the way to the root directory, and then it comes back up and it overwrites a file native to ASCII, a file which is actually being run every single time we create a new task. And what it does is it makes sure that if there are any non-ASCII characters, it provides an ASCII representation for those. So for example, if I was to go in and create something like, I don't know, the symbol for a new paragraph, for example, it wouldn't show that, it would show the ASCII representation of that. So what we're doing is we're overwriting that native to ASCII. If I was to cat that, all we're doing is we're echoing out something to say gotcha. Okay, so this is going to replace the title in our application. So I'm going to choose this file, I'm going to upload this. We can see straight away the good.txt falls into our public folder. So this is this file here falling into our public folder, but we cannot see this, which means this has gone unvalidated. Either it's been validated actually and it's been ignored, or it's unvalidated and it's actually overwritten this file. So the way to test for this is to come back and let's create another to-do. Let's say, I don't know, buy wife flowers again. And if I was to hit create this time, we call native to ASCII, but this time our native to ASCII file on the file system's been overwritten. As a result, we call my version. Okay. More common, perhaps, implementations of this is for me to actually, add new JavaScript into an application which everyone starts executing on their local machines. A whole bunch of things like this. If you use things like, I don't know, whatever, ZTZip or a whole bunch of other libraries that have been found to be vulnerable, you need to upgrade those libraries. If you are using zip entry, for example, in Java to extract from an archive, you need to make sure when you iterate through them, you are validating the file name doesn't start with .. or when you look at your full path, when you look at the canonical path, it actually is the same as the target directory that you're putting it to once you've concatenated target and the file name as well. So that's zipslip. I'm going to show you a few others. In fact, let's go to JavaScript now. We're going to show you a couple of interesting ones, and it is more fun hacking JavaScript. I'm going to show you a couple of, in fact, what I've done is already, if I was to go to snick.io, with snick.io, you can actually integrate this with your GitHub repositories and so forth. And what I've done is here, I've shown you, I've got a whole bunch of vulnerable projects here, and I'm going to show you one which is the same as this one called Goof. Where is it? Goof package.json. So this is our JavaScript version. And there are a whole bunch of vulnerabilities that we can see. The first vulnerability I'm going to show you is something called the ST. Where is it? The ST. Oh, there's so many STs. Here we go. Open redirect, not that one. Remote memory exposure, not that one. Let's just do a search for directory traversal. It's a directory traversal vulnerability in the ST folder. Okay, so a directory traversal, as we said, is a vulnerability that allows us to break free of that target directory. So let me show you this application, and then we can hack this together. In this application, we have a goof to do. This has a whole bunch of things. I can buy milk. I can buy beer. But if we wanted to buy beer, we'd probably put stars, because that's more important than milk. And it turns it into bold. Just a regular to-do app. It's also got an about. The about just provides information, serves us information from the public folder. So if we wanted to do a remote codec, if we wanted to do a directory traversal, how would we do this on this application? How would we break this application? Any ideas? Come on, you're hackers. Come on, I can tell. .. on the end of this about .. slashes. Okay, if we're going to pretend to be hackers, let's do it at a command line, because that seems like the cooler thing. So I've got some aliases, and what I can do is I can just curl the about HTML. This provides us with the regular HTML for the about page. But instead of this, we wanted to do a .. right? So here we'll just do .. like this. If I run this, we actually get the home page, and this is because this is a real application. This is a real library. This is the ST package. This is a library which is in use by many, many different applications around the web. So this understands we're trying to do directory traversal, and it stops us from doing it. So how else can we represent what we're trying to do here? Encoded dots. Okay. Do you know what an encoded dot is? Oh, I really thought you were a hacker then. Percentage 2e. That would have really impressed me. Percentage 2e, percentage 2e. If we were to do that, for example, who thinks that's going to work? One person. Well, you're right, it does work. If I was to show you that, now we get a full directory representation of what's in the public directory. What else can I do with this? Keep on going down. How many times? As many as I want? Yeah, because if I was to carry on going, what happens if you put cd ... when you're in the root? You get to the root, right? So if I was to do that again and again and again, where do I end up? In the root directory. What can I do now with the root directory? Well, I'm curling this. I could just put / etc. / password. And all of a sudden, I've got my etc. password. Okay? So using this directory traversal, you can actually gather information about the system. I can gather information about the config. I can see what's installed. I can see the configuration of what's installed. And I can gather information about my environment. So this is a really interesting kind of directory traversal that does lead to reading information. Again, it is only reading information, not writing or executing information. So this is just a medium traversal. But let's show you a more interesting one. This one is actually, if I was to come back here and go to the marked. So the marked package has this thing, cross-site scripting. Who hasn't heard of cross-site scripting? Right, no one. Okay, cross-site scripting. We all know what cross-site scripting is. It's effectively adding JavaScript, adding scripts, and having that executed by your web page, right, by your backend. So, if I was to come back to my runtime, how can we add cross-site scripting into this application? Type some code in here. What kind of code? A script, just like in my history there, huh? Oops. Script, something like this. And what would we do? Alert, the most boring of all the scripts, huh? But we know this works. So if I was to run that, who thinks that's going to work? You're starting to believe now, huh? This is like Neo getting out of the Matrix. No, because marked is actually a reasonable. Actually, it's not reasonable, because if I was to come here and I was to actually, if I was to cat the ... oh no, okay. If I was to just cat I think it's app, is it, or db? Where am I? To do. Here we go. If I was to cat the app.js, what we see, where is it? Right at the end here, we set the options on this marked library to say sanitize. Out the box, that would have actually worked. Okay, but we are adding the setting sanitization to be true. As a result, we sanitize the input and the output. So we are sanitizing this and saying, I know this is a script, but I'm not going to run it as a script. I'm going to show you the angled brackets like they're angled brackets. Okay. Now this is Markdown. So how else can we add a script in Markdown or add a link, a dangerous link? Escaping the special characters, so maybe doing something like this, but what? Maybe something like, oops. Something like this, but escaping these characters. Like this? The other way? Damn it. Oh, this. Who thinks that's going to work? 1, 2. Nope, no escaping. Any other ideas? We're using Markdown. So what else can we how else can we represent some bad script in Markdown? ASCII? That won't actually work, and the reason I'm just telling you that is because I don't know the ASCII representation of the angle brackets, so I'm not going to waste your time. A link? It's a good idea. So if we put a link, so if we say JNation like this, what's the URL again? Is it jnation.pt, right? So a link like this, that if I click, okay. So let's do that again. Instead of this URL, we put some JavaScript. So something like this. Who thinks that's going to work? It's in my history. Nope, it's actually sanitized. It's still there. It is still there, but it's being sanitized out, okay? I can tell you the bits it doesn't like is this colon and this closed bracket. So what next? Escape these, like this. Say again? Use ASCII characters? Okay. Who knows the ASCII for that? Right, I'll tell you. And I'm not really this sad, but I've done this presentation a couple of times. Okay, so 58 and 41. Who thinks that's going to work? Getting a bit more confident now. Still doesn't work. And the reason is because if I was to open this up, you can actually see it's represented them correctly. But marked is actually pretty good. The sanitize function is pretty good. But I'm going to show you how to break this because this is a tricky one. The way we're going to break this is we're going to break it by using the browser. The browser is actually very clever and very stupid at the same time. What we're going to do is we're going to represent this colon without actually fully representing that colon, this dot dot. What I'm going to do is here is if I type this, okay, this here is it's a reasonable command, but this doesn't actually fully finish because it doesn't have that semicolon on. So the marked library is going to say, yeah, that's fine. You're not putting a colon there, but the browser is going to say, I think I understand what you're trying to type. You're trying to type a colon, so I'm going to represent it as a colon. So even though we've passed the sanitization, as soon as I run this, all of a sudden then we get our link. When I click on that link now, you get your alert. Okay? Now, what bad kind of code can I put in here? Well, I can just grab your document, send your document to wherever. I can grab your session and do a whole bunch of stuff. Who was that? Say again? I could do some Bitcoin mining, perhaps, if I've got some spare time. That sounds good. Maybe earn a bit of money. So, a really interesting way whereby the vulnerability doesn't actually exist in the library, but exists together with the browser as well. Let me show you another one. Who likes regular expressions? Who likes reading other people's regular expressions? Every now and then I get one person put their hand up. Okay, a regular expression is actually pretty cool, but there's a couple of things that make them slightly annoying. They're pretty fast to match if there is a match, but when you have a regular expression, the runtime will actually try. It's very, very hard. It's going to use a backtracking algorithm to find a possible match with your string and your pattern. So, for example, if I was to type a regular expression like this, okay, and then I tried to actually pass it something like AAAA, something like that, it will match this really, really quickly. But there are a number of different ways this could match. It might entirely match just on the A+. Okay, because A+ is one or more, one or more A's. Okay, it might do the first one as A+, and the rest of them through stars. Okay, there are a number of different ways it can match. Now, if I was to actually put something like a B on the end, it would actually try and traverse through, backtracking, doing everything it can to try and match. And only when it realizes there is no possible match will it then try and fail. So this is called this is the way in which something called regular expression denial of services work. And I'm going to show you this running on this environment. I did this in Barcelona last week, and it actually worked just fine, and it's because I actually patched the server, and it was really annoying. But this time, I've made sure we are vulnerable. So in my runtime here, I'm just going to type, I think it's MS3. Now, MS3, in fact, let me just show you what MS is. Let's type MS1 first of all. If I was to do something like this, where I just send some content that says call mom in 20 minutes, if I run that, this is our payload here, and if I go back to my runtime, you can see call mum, and it's done regular expression. It's recognized that we have some text there, which is time, and as a result, it turns turns that into 20M for 20 minutes. Okay. Now, what I'm going to do this time is let's type MS3 again, rather than just be nice. What we're going to do is we're going to say buy milk, but we're going to buy it in fact, let's be nice first. We're going to printf 60,000 character 5s and then add minutes at the end. If I run that, it actually runs pretty quick. And it runs quick because it finds a match straight away. If I was to come back to my runtime, we say buy milk in infinity days. That's pretty accurate, I guess. But what this time we're going to do is rather than allow it to match, just before we hit minutes, I'm going to change that to minute A. And what it's going to then do is it's going to backtrack. Because it can't match minutes, it's going to backtrack around those 60,000 5s and try and find a match. As a result, when I execute this, we're hanging. It's backtracking right now, trying to find a match. If I was to come over to here and I was just to type hello, I can type that as many times as I want. We're hanging. We're getting a denial of service. Now I know, and I'm going to get my timing right one of these days, that any second now, damn it, any second now, that's going to resolve and we get all our hellos, okay? So that, if I was to add another 0 onto the 60,000 to make it 600,000, we would be here till tomorrow before this actually resolved. So, what use is this? Well, you can effectively send a number of these requests and have a denial of service on your monolith or your microservices. If you're using serverless, which is very, very good at expanding, it's just going to cost you a hell of a lot of money because every time one of these gets sent, you're grabbing, you're extending, you're growing your environment. Okay, so I have about 10 minutes left. So, actually, shall I show you? Yeah, I'll show you another. I'll show you another one. I'm going to show you my new About page. It's very, very similar to my previous About page, but I have a couple of modes on here. What I can do is I can say on my About New, I can actually provide some information to this server, or this is actually node, to this, and it'll potentially give me a different CSS, different page, depending on my device. So what I can do here is I can just put device equals desktop, so let me show you this, device equals desktop here. As a result, you'll see this is the extent of my CSS, unfortunately, but you'll see it gets slightly smaller, okay? You can also see here we've got some debug string as desktop. Okay, now we know we're getting into some code and we're passing a string. What can I actually do to start looking at hacking this? Well, what I'm going to do to start off with is I'm going to do this. Now, this is on the end of. Oops, let me zoom. On the end of this desktop, I'm going to add this console.log passing in gotcha in quotes. So let's see if this is now going to automatically execute. I run this, and what happens? Whoop. What happens? We get this gotcha out, but if I go to my console log, we get this gotcha here. But this is just the text I'm passing in. We're not actually getting the console log. Otherwise, we would just see gotcha here. Okay. So this is being sanitized. This is being checked and validated. However, the validation is occurring because it checks for a string. It checks whether we're passing a string. And based on the type that comes in, that will kick off whatever sanitization we have. Now, anyone know how I can change this from a string to something else, just with 2 characters? Quotes? No quotes. On the end of device. No. I'm going to add an open close bracket. All of a sudden, the type of that turns from a string to an array. We pass the sanitization, it then gets flattened into a string, it gets read as a string, but if I execute that and then come back to my runtime, all of a sudden we get gotcha out here. And this is called type manipulation, where you do things on a particular type, and if that type changes, then all of a sudden you're not running certain checks. Okay, so it's very, very important to make sure that what's important to you is being done on a number of types. Don't just expect certain types to be passed to you. Right, 7 minutes. This really is all I can show you in terms of some hacks. So let me actually go run through. This is the issue, but how bad is the issue? Well, we have the state of open source security. This is a report which we actually created last year, and we can see for NPM, for example, open source is really taking off. This is pretty much doubling the number of packages downloaded per day, every single day, from 200 million up to 400 million in just a year, a single year. If we look at the number of packages that have increased over different ecosystems, we can see Maven here, the number of packages that have been included in, or have been indexed in Maven Central has increased by almost 30%. How many of 430 sites show at least one front-end vulnerability in the application? What do you think? What percentage of those sites have at least one known front-end vulnerability? 12, 50, any others? Higher, 85? 77, over 3/4 of these sites which we scanned have known front-end vulnerabilities. Here's something that Java does win over Node, the number of critical package vulnerabilities over time. You can see Java is really increasing, so yes, go Java. The number of open source vulnerabilities per year, we can see this kind of hockey stick approach, right? The number of open source vulnerabilities is massively increasing. This is for a number of reasons. One, because adoption of open source is rapidly increasing, right? Another one is because attackers are massively targeting open source because, again, one vulnerability leads to many victims. Project maintainers typically only have about 16 days before they go from understanding there's a problem to fixing a problem, but vulnerabilities tend to exist, and these are median averages, by the way. Vulnerabilities tend to exist for a couple of years, 2 to 3 years, before they're even found, before they're even known. When we look at how good open source maintainers are when it comes to their knowledge about security, well, in terms of security know-how, less than 20%, less than half of open source maintainers have had audits, security audits. So the code that we're using, it's very important we understand at what level of security is actually being tested on those. Let's take a quick look at Docker. What percentage of 1,000 of Docker containers, the top 1,000 Docker containers, have known vulnerabilities? Docker's cool, right? There can't be that many known vulnerabilities in Docker, right? What percentage do you think? 35, any others? 90. 76.6, just under the previous number, in fact, of 77, right? 77.3. Again, over 3/4 of the top 1,000 Docker containers have known vulnerabilities in them. So what's the solution? Well, there's a number of things that we need to put in place to actually fix this. Team culture. Okay, understanding that security is an issue that we all have to deal with. Process, and not just adding new process, because no one likes new process. We need to make sure that the tooling we use, that the additional things that we do are existing in the development process. So let me show you what we can do, for example. In this Snyk environment, Snyk is a tool which will allow you to do this, and everything I'm going to show you is completely free for you to just go download, try, play. What I'm going to do is, here in this demo application, for example, there's a whole bunch of these known vulnerabilities. In this example application, for example, has 411 dependencies. There are 31 vulnerabilities, and there are 66 different ways of getting to those vulnerabilities through the dependency trees. What I'm going to do is I'm going to click on this simple button, Open a Fix PR. This is actually going to create a pull request. First, actually, it's going to ask me which of these vulnerabilities I want to either patch or upgrade to a version which doesn't have that vulnerability. I'm going to be a bit cowboy, and I'm going to do them all at the same time. I'm sure everything's going to be fine. I'm going to click Open a Fix PR. It prepares, it creates it, and Wi-Fi willing, we're going to get a fix PR. There we go, created against GitHub. This is actually GitHub Enterprise. And here, if I was to click on the files changed, you'll see which patches are created, so the pieces of code which are going to overlay onto your vulnerable projects, as well as the fixed versions which we have. We actually host our own Snyk database, which is an open source database, free for everyone to use again, and you can find which versions your vulnerabilities exist up to. As a result, we can tell what version is the latest version, is the closest version to the one you're currently on, which doesn't have that vulnerability. We don't just want to pull you up to the latest version because you're going to have loads of problems in your application. But we want to pull you slightly to a version which doesn't have that vulnerability. So here, for example, we're going from 1.9 on Body Parser to 1.17.1. We're going from 1.2 to 1.43. These are the versions which we know have these fixes in. As a result, I can then merge this and go through my CI environment. go through my full test environment. Another thing we could do if we wanted to is we could actually use the SNCC CLI. So here I could actually run SNCC test. That's all I need to do. I've actually done an npm install SNCC just before this. If I run SNCC test, this is going to query the vulnerability database against our dependencies that we have. And as a result, we find all these severity vulnerabilities, medium severity, high severity, and a whole bunch of other vulnerabilities. I can then add a monitor onto this, so I can check which vulnerabilities are in my runtime, in my production runtime, so that if we're not going through this full check every time we build, we can still know when known vulnerabilities exist in code that we've already deployed. So all of this that I've shown you, either as a developer doing it in GitHub, using the SNCC test in your CI environment, using the monitor so that we can test against our production environment. All of this is available. All of this is free. If you wanted to use it for enterprise, there's going to be some enterprise-style costs involved. But all of this is free to a certain extent for everyone to use. And it's available for us to implement throughout our security, throughout our development focus. How much time have I got? Not much. The last thing I'll actually talk to you about is application architecture. And this actually just covers very, very gently about how your architecture will have different implications on the types of security problems you might have. Let's take a look at monolith. Okay, who's using a monolith here? Yeah, don't be frightened. Monoliths are cool. Who's using microservices? Who's using serverless? Not a single person. One person. No, not a single person. So, okay, monolith, you have one big application. You have one perimeter, effectively. If someone breaks through, they might actually be able to get use of more, more services, more kind of things. If you're using microservices, you have a whole bunch of different services. You have a whole bunch of perimeters covering your services. Do you use HTTP between them? HTTPS? Are you prone to man-in-the-middle attacks if you're using HTTP, people sniffing around your services? If you're using serverless, then you know your infrastructure is being recycled very, very quickly. As a result, your infrastructure isn't going to last long enough for people to sit there for a month, for example, because your application is going to be up and down all the time. Other things like your infrastructure with serverless, your infrastructure is likely to be patched to the latest versions. You're not necessarily running on a monolith, perhaps, that isn't patched very often in terms of the underlying platform. There's a whole bunch of different considerations that you need to have between your architectures. But for now, and for 50 minutes, that's everything I have. So first of all, thank you very much for being here. I hope you had an awesome session. Thank you. Yes, Nicholas. Okay, right. Yeah. So great question. So the question was, if you're running with a Java Security Manager, how many of these different types of vulnerabilities will be fixed? Well, I think the Java Security Manager, it does help a lot. It does help a lot. There are a number of things which we need to consider, though. In the same way with different tests, different quality tests, we have a whole bunch of different tests that we do at different times. The security manager is only a runtime thing. And I think while the security manager does protect our runtime and probably will cover probably 30 to 50% or something, reasonably significant of these known vulnerabilities, there are certain things which it won't necessarily pick up on, won't necessarily find, because from whether it's been poorly configured, whether it's not being used, whether there are certain instances where you find an alternate way to get into a system. From a knowledge gathering point of view, you might have enough, all you need to actually find other things. So the Java Security Manager will, by its very nature, stop application threads from doing things they shouldn't do. But as with everything, it's very important to make sure you are covered completely, because we can never predict our runtime. So it's still very, very important if we know we have known vulnerabilities, just to eliminate those. But yeah, the Java Security Manager is something which will fix a lot of those vulnerabilities, but not necessarily everything from an attacker's point of view. Yeah, yeah, good question. Any other questions? Anyone want to try hacking? If you did want to, if you go to github.com/snick, there's a whole bunch of those applications which are available with an exploits folder, and you can actually download and install and have a play and actually hack those applications for yourself. It's actually good fun to do. Please don't hack real applications because it's illegal and quite rude. But awesome. Thank you very much.